Hi, this video clip is intended to create a study case to demonstrate the use of a C integrator to obtain the useful biomedical research information by integrating clinical data and genomic data. In particular, I would like to demonstrate the use of a C integrator to explore the differential gene expression patterns in a few genes, with a few genes that in the different subtype of um, glioblastoma tumor. This kind of analysis and the data derived from this kind of analysis can lead to the discovery of potential therapeutic target or diagnostic markers. The study that I choose is TCGA Radiology C Integrator. It's captured in the NCI instance of C Integrator. It's made available to the public, which means anybody can access and explore the data associated with a particular study without login. Let's look at the data that we're going to use for this particular analysis, that is the clinical data and the genomic data. And the clinical data is collected and stored in C Integrator from a group of patient with glioblastoma. The information includes the subject ID, like it's basically patient ID, and the subtype of tumor of each patient had, genes, gender, survival days, and some other useful information. The genomic data is basically gene expression data derived from microarray assay. The assay was done by with the data collected from the same group of patients. And originally the data was stored in CArray, and during the creation of this particular study, the CArray gene expression data is extracted and now stored in CA Integrator. The tools we're going to use is a gene expression plot. Let's click on that. So what this tool does is to associate the gene expression levels of chosen either one gene or list of gene with particular subject annotation parameters that you choose. Let's say, for example, I would like to look at the expression of oncogene epidermal growth factor receptor, and I want to report on gene, and I want to look at in the patient with different subtype of tumor. Now we see the 4 different subtypes of glioblastomas listed in the value column. So what we just did is that we created a query to ask the integrator perform analysis on the genetic data and clinical data, and give us the mean expression level for EGFR gene by 4 different types of by 4 different subtype of tumor. So when we click on create a plot, the C Integrator will perform analysis and present us with this graph. So this graph showed the mean expression levels of EGFR in 4 different subtype of tumors. It is not difficult to say that in the classical subtype of tumor, the expression of this gene is obviously much higher than the level of expression in other 3 types. Just by viewing that, it looks like at least 2 times higher. So this indicates that this gene probably can be used either as a marker or as a therapeutic target for this particular subtype of tumor type. So let's look at the list of other genes. Let's choose P53, and let's also look at platelet-derived growth factor receptor alpha type. And here's a list of 3 genes. We want to look at expression pattern of the 3 genes by the same for different subtypes of tumor. And when we click on create plot, now what we have is the gene expression patterns of the 3 genes we selected for different subtype of glioblastoma. Okay, you can see that the expression level p53 in 4 different subtypes, which is represented as a yellow, as a green bar here, they're pretty much the same. And if you look at the expression level of PDGFRA, which is represented here as a blue bar, it's very obvious that the expression level in proneural subtype is much higher than the expression level in the other 3 subtypes. Just by visual inspection, it's at least 4 times higher. So this indicates the PDGFRA may be used as an indicator for as marker or target for preneural subtype of glioblastoma. And the EGFR we have mentioned before has much higher expression in classical subtypes of glioblastoma. So the gene we choose here, EGFR, PDGFRA, is where the overexpression in certain type of subtype of glioblastoma has been very well documented. But the same method and this same kind of analysis can be performed on other genes and other different clinical annotation parameters. It can be used to explore unknown associations of one gene or list of genes with, let's say, different type of tumor or different genders or different age groups. So this information, as I mentioned before, can lead to discovery of potential novel therapeutic targets for particular type of for particular related to particular clinical annotation parameters, and it can also lead to the potential diagnostic markers. So I hope this presentation is clear and it's been useful. Thank you.